Let us convert 12 degrees 10 minutes to radians. So first, let us use decimal degrees instead of degrees and minutes. 12 degrees plus 10 minutes, that can be represented in degrees as 10 times 1 minute, and 1 minute is 1/60th of a degree. So we have 12 plus 10/60th or 1/6 of the degree, which is the same as 12.1666. Is repeating any decimals, so we can round it somewhere in the 5th digit after the point. Now let us convert it to radians. So we must multiply by pi over 180 or 180 over pi. It is easy to choose which fraction when you remember that we want to get an answer in radians. Radians are often represented in terms of pi, so we want to get answer with pi, and we want to read over degrees. So our degrees we divide by 180. So degrees are, so to say, cancelled out, and pi remains in the answer. So now we have to multiply 12.16667 times pi divided by 180. So when we multiply fraction by a number, we multiply only the numerator by this number. And it will be approximately 0.0676 radian. We have 3 significant digits in the beginning and 3 significant digits at the end. When we want to convert the number containing pi in radians, we just replace pi with 180. We want to convert negative 3 pi over 2 into degrees. Pi is equal to 180 degrees. So we just replace pi with 180. Negative 3 times 180 degrees over 2. And simplify the fraction. We can divide by 2 numerator and denominator, get 90. Above 90 times 3, 270, negative 270 degrees. 5 radians. We must multiply 5 by the fraction, so the similar fraction, but the reciprocal of it. 180 degrees over pi. So now we want to get the answer in degrees, so 180 must be in the numerator. So here we need to take a calculator and get the approximation of the answer, 286.48 degrees. So approximately. Now let us convert 225 degrees to radians. We can do it as we have done previously by multiplying times pi over 180. We can do it in a different way. We can find this angle on the Cartesian plane. So maybe you remember already that in the first quadrant is 90 degrees. So this is 90 degrees angle. The straight angle is 180 degrees. Then we have 270 at the negative y-axis and 360 on the positive x-axis. Also, you know that pi is the same as 180 degrees. The straight angle is In radian, it is equal to pi. In degrees, it's equal to 180 degrees. And maybe you remember already that 225 degrees is in the middle of the third quadrant. So it is 180 plus 45, and we get 225 degrees. One quadrant is 90 degrees. A half of the quadrant is 45. 45 degrees, or pi over 4 radians. 90 degrees, or pi over 2 radians. Then the next quarter of the second quadrant will be 1, 2, 3 pi over 4. Then 4 pi over 4, or pi, is 180 degrees. The next quarter of the quadrant of pi is pi. 4 pi over 4 plus pi over 4 will be 5 pi over 4. Then the next quarter of pi plus pi over 4 will be 6 pi over 4, or 3 pi over 2. Then the middle of the fourth quadrant will be plus another pi over 4, 7 pi over 4. And the complete rotation is equal to 2 pi, or 8 pi over 4. So if you represent the circle as 8 quarters of pi, it will be easy for you to locate and identify such angle as pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, as well as the half of pi, pi over 2, pi, 3 pi over 2, 2 pi, or 0. So now we got that 225 degrees is the angle 5 pi over 4. Now let us find sine of pi over 4. Pi over 4 is the half of a right angle, is in the middle of the first quadrant, and is the same as 90 over 2, or 45 degrees. So sine of pi over 4 is equal to sine of 45 degrees. It is an easy way to remember what is the value of 45 degrees trigonometric function. So if you take a square with the side 1, then according to Pythagorean theorem, the hypotenuse will be equal square root of 1 plus 1, or square root of 2. And it divides the square into two 45-45 triangles. So if you consider this one of these angles, its sine will be opposite over hypotenuse. So sine of 45, or sine of pi over 4, equals 1 over square root of 2. We can also rationalize this answer by multiplying the square root of 2 numerator and denominator, and get square root of 2 over 2. Let us find now cosine of pi over 3. So pi is 180 degrees. And if you divide the pi, or the straight angle, into 3 parts, you will get 3 equal parts: pi over 3, 2 pi over 3, and pi is 3 pi, the same as 3 pi over 3. Then we can add another pi over 3. It will be 4 pi over 3. plus pi over 3 will be 5 pi over 3. And on the positive x-axis, we have 360 degrees, or 2 pi, or 6 pi over 3. Pi over 3 is 180 over 3, or 60 degrees. 2 pi over 3, 2 times 180 over 3, 120 degrees. 4 times 180 over 3, or maybe it is easier, 180 plus 60. So if you divide by 3, then all these increments are 60 degrees. So we have here 180 plus 60, 240 degrees. And the last one, 5 pi over 3, or 360 minus 60, since it is also 60 degree angle. 360 minus 60 will be 300 degrees. So, and we can also add pi over 6 to this picture. Pi over 3 divided by 2 will be pi over 6 in the middle. Pi over 6 will be 60 divided by 2, 30 degrees. Here we can also add pi over 6. How to find this angle? So the reference angle is pi over 6, so 30 degrees. Here we have pi, or 6 pi over 6, so minus 1 pi over 6 will be 5 pi over 6. If you want to find this angle in degrees, we know that straight angle is 180 degrees. We subtract 30 and get 150 degrees. When we add 30, we will get 210 degrees. Or if we add pi over 6 to 6 pi over 3 over 6, we will get 7 pi over 6. The next is 8 pi over 6, or 4 pi over 3. Then, and the last one we have here, 360 minus 30, or 330 degrees, or 2 pi is the same as 12 pi over 6. I multiply 2 pi over 1 by 6, numerator and denominator. 12 pi over 6 minus 1 pi over 6 is 11 pi over 6. So, and all these angles are special angles. They can be found, the value, the trigonometric functions of this angle can be found from the trigonometric functions of the 30 and 60 degrees. Or we consider such a reference triangle. If you take an isosceles triangle with the side length 2 and divide it into 2 halves, so that the lower side, the side on the bottom, consists of 2 ones, then you will get 2 right triangles. In the isosceles triangle, each angle is 60 degrees. The half of this angle is 30. So you see that for we have 30-60 triangle, and we can find all the trigonometric functions of 30 and 60 degrees from this triangle. We need only to know the length of this leg, which will be, let us call it x squared plus 1 squared equals 2 squared, and we can solve it for x equals 4 minus 1, 3, x squared, so x equals square root of 3. So we can find sine and cosine of 30 and of 60 from this triangle. So this time we have cosine of pi over 3, or cosine of 60 degrees. So we consider this angle on the bottom. Cosine is adjacent over hypotenuse. Adjacent is 1, hypotenuse is 2. 1, so adjacent over hypotenuse, 1 over 2, 1/2. So cosine of pi over 3 or cosine of 60 degrees is 1/2. And now let us find sine of 3 pi over 2 and cosine of 3 pi over 2. So first let us locate this angle in our Cartesian system. So pi over 2 is 90 degrees, and we have here 3 pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. 3 pi over 2 is here. So in the smaller increment, it is also 9 pi over 6 that I skipped last time. Oh, in degrees, it is 270 degrees. So sine is, by definition, y over r. If we take the radius of this circle to be 1, then y at this point equals to -1. X equals 0 and y equals -1. So we have -1 divided by 1 equals -1. Sine of 3 pi over 2 is -1. Cosine of 3 pi over 2. Cosine is, by definition, x over r. X at this point is 0. X coordinate of this point is 0 divided by 1 is 0. So cosine of 3 pi over 2 is 0. Let us find also cosine and sine of -pi. So pi is a straight angle or 180 degree. When it is negative, we move in opposite direction, in clockwise direction. So actually it is the same point as pi. Pi or -pi will land in the same point. The coordinates of this point are -1 and 0, first the x coordinate, then the y coordinate. Sine of -pi by definition is y over r. R is always 1 on the unit circle. Y is 0 at this point. So 0 over 1 or 0. Cosine of -pi is x over r. X is -1 at this point. So -1 over 1 equals -1.